friends, I am Akshay and welcome to TeKnowledGeek. In the Big Data Interview question series, today as a part 2, we will cover the HDFS. Let's begin. Please watch till the end. So first question is, what is Hadoop? So Hadoop you can think of like a software framework or an ecosystem of softwares. So Apache Hadoop basically is a collection of open source software utilities that facilitates using a network of many computers to solve problems involving massive amount of data and computation. It provides a software framework for the distributed storage and processing of big data using the MapReduce programming model. So it comprises of two things mainly. First is HDFS, a distributed storage file system, and for processing it use MapReduce. The Hadoop consists of Hadoop common packages, which is like some libraries and utilities which is used in the MapReduce or HDFS. Second is the processing engine, that is MapReduce. Third is the distributed file system, which is Hadoop distributed file system. The term Hadoop is often used for both base modules and the submodules, and also the ecosystem, which is collection of additional software packages that is added extra in the installation alongside Hadoop. So you may think of the scripting language is Pig. Next you can have a query interface, it's Hive. You have a NoSQL database like HBase. You have a data ingestion framework like Scoop. And then for coordination it will use Zookeeper. For the workflow and scheduling it can use Uzi. And for the manage and monitoring it will use Ambari. So this way you can think of a very basic model of Hadoop ecosystem. Second question is, what is HDFS? HDFS or Hadoop Distributed File System is a distributed file system and a logical layer of over the underlying OS file system. So the first question is, what is distributed file system? File system that manage the storage across a network of machines are called the distributed file system. Since it is a network of machines and whole distributed file system is network based, so there are challenges like making the file system tolerate node failure. So why node failure? Because it comprises of commodity hardware and very cheap hardware you can think of. So it can fail too often. So the distributed file system should also take care or fault tolerant of this node failure without suffering data loss. So the key features of HDFS is, first, HDFS, though it is a network based distributed file system, it is highly fault tolerant using the replication factor. Second, it is designed to be deployed on low cost hardware or the commodity hardware, and it believes in scale out, not scale up. Later, it is used in the high-end hardware as well. HDFS provide high throughput access to the application data. High throughput access because it is suitable for the application that have large data set. But as a drawback, you can think of a very fast transaction processing system. It requires a low latency throughput, but Hadoop cannot or HDFS cannot provide you that. So it compromises on the low latency to give you a high throughput access. So now we will discuss about the basic components of HDFS. So what is NameNode and DataNode and how they works? So HDFS has a master-slave architecture. So NameNode is the master server that manages the metadata of the file system, like the file system namespace and the replication factors and the blocks, the header of the blocks, you can say. So there in the slave side there are a number of data nodes, usually one per node in the cluster, which manages the storage attached to the node that they run on. The name node executes file system namespace operations like opening, closing, and renaming files and directories. It is also determines the mapping of blocks to the data nodes. Like if you have a name node, it will have the which part of the file it has, and then which rack it belongs, and then the number of replicas, and then the block ID. So you can say the block 2 belongs to the data node 1, 2, and 4. The data nodes are also responsible for the serving read and write request. So metadata operations on the name node and the file read write operations is on the data node. The data node also perform the block creation, deletion, and replication upon the instruction from the name node. Next question, you may see why HDFS block size is high. So you can have a like calculation here. So if you have very large data set, to have like the block metadata lower, you need to have a bigger chunk of it. Otherwise, if you have divided the blocks into very small fragment, then the block metadata will be very high. And second thing is that the seek time, like to find the start of the block. So if you want to reduce the seek time, then you can think of one problem, like if your data transfer rate is 100 megabyte per second and your seek time need to be kept at 1% of the transfer time, so what will be the block size for 10 millisecond seek time? So if 10 millisecond is the seek time, then the total transfer time is 1 second, and the data block size according to your data transfer rate will be 100 MB. So to keep the seek time even at the 10 millisecond, you need to have the block size of 100 MB. So that is why if you want to reduce the seek time and keep it like 1% of the total transfer time, then you need to make the block size very high. And HDFS, you know, is designed to support very large files. So applications that are compatible with HDFS are those that deal with large data set. These applications write their data only once, but they read it one or more time and require these reads to be satisfied at the streaming speed. HDFS supports write once and read many semantics on files. A typical block size used by HDFS is 128 MB. So an HDFS file is chopped up into 128 megabyte chunks, and if possible, each chunk will reside on a different data node. So if you have a 612 megabyte size of file, so there will be 5 chunks. 4 of them will be 128 megabyte and one of them will be 100 megabyte. In that way, you can define your blocks. How can you access files from HDFS? So there are many ways to access the files from HDFS, but the most common is the FS cell. So FS cell include various cell-like commands that directly interact with the Hadoop distributed file system as well as other file system that Hadoop supports, such as local file system or web HDFS or S3 file system and others. The FS command will be like Hadoop FS and then the arguments to do your particular job. There are some common and useful FS shell commands like cat, copy to local, copy from local, copy, ls, put and remove. So these are mainly used. A typical HDFS install also configure a web server to expose the HDFS namespace through a configurable TCP port. This allows a user to navigate the HDFS namespace and view the content of its file using a web browser. Next question is, what is HDFS federation? So first we will think about why the federation is required. So the name node, since it's a master node, it may be served as a bottleneck for scaling up or scaling out a very large cluster. So if you have like 10,000 if you have the 1,000 nodes in a cluster and if you save every metadata in the name node, the single name node, that name node memory size can be a bottleneck for scaling a very large cluster. HDFS federation allows the scaling of a cluster by adding name nodes, each of which manage a portion of the file system namespace. Under federation, each name node manages a namespace volume, which is made of metadata of the namespace. And it's not interchangeable and no name node communicate with each other. So that is not ensuring the high availability. It's just having one single node memory is a bottleneck. To erase that problem, we have the HDFS federation. A block pool contains all blocks for the files mentioned in the namespace, and that block pool is exclusive to a particular name node. Next question is, what is HDFS high availability? So HDFS federation, and if you have a secondary name node also, that is not a high availability or highly available file system. Name node can still be a single point of failure. The Hadoop 2 remediate this situation by adding support for the HDFS high availability. In this implementation, there are pair of name nodes in the active and standby configuration. In the event of a failure of the active name node, the standby takes over its duties to continue servicing client requests without a significant interruption. Now, in the high availability architecture, we will discuss what is failover and fencing. The transition from the active name node to the standby name node is managed by a new entity in the system called the failover controller. There are various failover controllers, but the default implementation uses Zookeeper to ensure that only one name node is active. Each name node runs a lightweight failover controller process whose job is to monitor its name node for failures using a simple heart beating mechanism and trigger a failover whenever the name node fails. The name node high availability architecture can be a QJM, the Java machine, or the NFS as well. The QJM only allows one name node to write to the edit log at one time. However, it is still possible for the previously active name node to serve stale read request to the clients. So setting up an SSH fencing command that will kill the name nodes process is a good idea. Now we will discuss what are the storage types and what are the storage policies in HDFS. The first phase of the heterogeneous storage changed data node storage model from a single node storage which may correspond to the multiple physical storage media to a collection of storage with each storage corresponding to a physical storage media. It also added the notion of storage type, disk, and the SSD, where the disk is the default storage type. A new storage type, archive, which has the high storage density but the little computing power, is added in the supporting archival storage. Another new storage type, RAM disk, is added for supporting writing single replica files in memory. So we have the storage policies like hot, where it is used for both storage and compute, like highly available and highly frequently used data is kept in the hot storage. So when a block is hot, all replicas are stored in disk. If it is cold, then all replica are kept in archive. If it is warm, then it is partially some storage, some replicas are kept in disk and some kept in archive. All SSD for storing all replicas in SSD. One SSD is the one of the replica in SSD and the rest are in disk. For the lazy persist is like first written in the RAM disk and then lazily persisted on the disk only, and the provided is for storing data outside HDFS. So these are the storage policies you can see. And if you want to see the what is your storage policy, you can write the command Hadoop storage policies list storage policies. What is HDFS disk balancer? Disk balancer is a command line tool that distributes data evenly on all disks of a data node. Data can have uneven spread between disks on a node due to several reasons. This can happen due to large amount of write and deletes, due to disk replacements, and this tool against a given data node and move block from one disk to another. The disk balancer is not enabled by default on a cluster. If you enable dfs.disk.balancer.enabled to be true in the HDFS site XML, then only disk balancer will work. And the disk balancer operates by creating a plan and goes on to execute that plan on the data node. A plan is a set of statements that describes how much data should move between two disks. A plan is composed of multiple move steps. A move step has source disk, destination disk, and number of bytes to move. A plan can be executed against an operational data node. Disk balancer should not interfere with other processes since it throws how many data is copied every second. Thank you so much for watching this video. Please subscribe for more videos. As you know, the more parts will come in this interview question discussion. Thank you so much once again.